So as we are dealing with the harmonic oscillator problem, we had formulated various methodologies in solving the same problem. The problem is quite important one in entire physics. We had solved harmonic oscillator problem in various methods in both classical and quantum physics. The WKB approximation is the easiest method in terms of mathematics in solving the harmonic oscillator problem. It is simpler to adopt the WKB approximation, the methodology to solve the harmonic oscillator energy eigenvalue. So the question be like, obtain energy eigenvalues of a harmonic oscillator using WKB approximation. The reference I had used here is Modern Quantum Physics, Quantum Mechanics by G. Aruldas. From the chapter, there's a problem. It is from a problem in the exercise section of the G. Aruldas quantum physics textbook. So we start with the basic idea of harmonic oscillator. In a harmonic oscillator, actually the turning points occurs where the potential is equal to the energy. That is, the V is equal to E. The classical turning points occurs where V is equal to E. So we have also that's the V is equal to 1 by 2 m omega square x square, which is a general formula or general format of the potential V. So if you take x1 is equal to minus 2e by m omega square the whole raised to 1 by 2 and x2 is equal to 2e by m omega square y the whole raised to 1 by 2, the condition for E or V can be satisfied. That is, E is equal to half m omega square x square can be satisfied by taking x1 and x2 as mentioned here. So for a particle constrained to move between x1 and x2 in a potential well, so consider a particle. The particle is said to be moved between the points x1 and x2 in a potential well. The energies can be obtained by the condition. So what is the condition of WKB approximation? 2 into integral x1 to x2 p dx is equal to n plus 1 by 2 h, where n is equal to 0, 1, 2, etc. So using this condition, it is very simple to formulate a methodology to solve the harmonic oscillator problem. We have E is equal to, so what is the formula for E? E contains both potential and the kinetic energy. So E is equal to P square by 2m plus V of x. Here V of x is equal to 1 by 2 m omega square x square. So E is equal to P square by 2m plus 1 by 2 m omega square x square. So from this we could solve P. So what is P here? P is equal to 2m E minus 1 by 2 m omega square x square the whole raised to 1 by 2. So still this step, it is simple mathematics that we solve P from the equation for energy, that is energy is equal to the summation of kinetic energy and the potential energy. So what we are going to do is that we are going to put the value of P in equation number 1. So equation number 1 is 2 into integral P dx is equal to n plus 1 by 2 h. So we are making bit adjustment here, pure mathematical adjustment just to satisfy this condition. So what here we do is that actually there is a 2 in the LHS, we are avoiding the 2. I will say how we had avoided it. Integral x1 to x2, we substitute the value for P here, and we had taken this 2 to the other side, so that is h by 2, and we multiplied a pi here so that we could divide 1. So this h can be converted into h bar or h cut, and there will be a pi here. So simple, it is x1 to x2, 2m E minus 1 by 2 m omega square x square the whole raised to 1 by 2 dx is equal to n plus 1 by 2 pi h cross or h cut, where n is equal to 0, 1, 2, etc. Now we could evaluate this by just substitution. By substituting sine theta is equal to m omega square by 2e the whole raised to 1 by 2 x. So we put by substitution we put sine theta is equal to m omega square by 2e the whole raised to 1 by 2 into x. So how could the limit changes? From x1 to x2, the limit changes to pi minus pi by 2 to pi by 2. So we could easily write this as integral minus pi by 2 to pi by 2, 2m the whole raised to me the whole raised to 1 by 2 cos square theta 2e by m omega square the whole raised to 1 by 2 d theta equal to n plus 1 by 2 pi h cut. Now it's simple to solve this equation. We could take 2e by this thing outside, so we get 2e by omega after cross cutting all the terms by here and here. we get 2e by omega the whole raised to minus pi by 2 to pi by 2 cos square theta d theta equal to n plus 1 by 2 pi h cut. Before starting this problem, we are sure about the eigenvalue solution of the harmonic oscillator. It is we should get En is equal to n plus 1 by 2 h cot omega. So we could get 2e by omega. So integrating this term, we get, obviously it is integral minus pi by 2 to pi by 2 cos square theta is pi by 2. E is equal to n plus 1 by 2 pi h cut. So we here cutting 2 and 2 here, we get e pi by omega is equal to n plus 1 by 2 pi h cut. Pi and pi can be cancelled from both sides. Solving for e, we get n plus 1 by 2 h cut omega. So we can easily find the ground state energy or the 0 point energy by putting n is equal to 0. Putting n is equal to 0, we get e is equal to 1 by 2 h cut omega. So actually there is a 0 point energy which is not 0 here. We have an obvious energy of 1 by 2 h cut omega, which is actually, if you recollect, it is actually a manifestation of Heisenberg's uncertainty principle. So this is all about solving, easily solving the harmonic oscillator problem using WKB approximation method. Thank you.